Well, welcome back to Virtual Astronomy Live. I'll tell you, Don here, right up above me, was so interested in the show, he was watching it before he joined the call. And so he was letting us all hear what we said twice there, all taken care of, no big deal. Don, thank you so much for joining us today.
Oh, it's a pleasure. We have this happen on space station between the the Russian comm system and the NASA comm system, and sometimes we get the two loops tied, and it makes this nasty echo. So for a minute there, I just thought I was not here, but back on space station.
Don, if it happens on the space station, I feel okay with it happening here. That makes me feel a lot better. Are y'all ready to get going? We have some awesome astronaut photos, some awesome imagery to look at and stuff like that. Summer, are you ready to take it away?
I am.
All right, so you are clear to do the introductions. I've already thanked the sponsors.
All right, fantastic. So, hi everybody. I'm Summer Ash. I am a former engineer and astrophysicist, now turned science communicator. And I just love talking about space. And so I'm super excited to be here today to talk about photography from space, art and photography inspired by space. And my guests today, or our guests, I'm getting all cocky now, are Don Pettit. He is a veteran NASA astronaut and flew 3 space flights, 1 shuttle, 2 missions to the space station. And I think spent over a year in space cumulatively, which is a lot of time. And he's also an avid photographer. And so he has quickly established himself as an outstanding space photographer from orbit. And what you might not know about him, or if you're a super geek like me, you would know that he invented a coffee cup that works in space, which is very, very cool. Also here today is Andrea Meado.
Meado.
Meado, thank you so much.
Okay.
I missed the tech check. And Andrea is based at Johnson Space Center in Houston, Texas with NASA. And she works in the Earth Science and Remote Sensing Unit, which is in this cool division called the Astromaterials Research, Exploration, and Science Division, which just sounds like a very cool thing to have on your business card. And she's a geoscientist. And one of the things she does now is train astronauts to take photos from space, especially ones that can be scientifically useful. And another fun fact about Andrea is she's an artist herself and has done some stained glass art inspired by photos from space, which we will hopefully get a peek at later as well.
Yeah, maybe.
But Andrea, I actually wanted to start with you because I was really curious how, as a geoscientist, you came to work at JSC, and if your research in school, did that involve using imagery of Earth from space?
Yeah, so I work for a contracting company at Johnson Space Center as a geoscientist, and going through grad school and undergrad studying geology, I actually studied a lot of igneous rocks, and I was interested in kind of faults, tectonics in general. And that's not what I work on at all here, but the same principles apply. If you have a general knowledge of geology of the Earth and other planets, it can be applied to imagery analysis as well.
And so did you use space imagery in any of your studies? Or did you get to go into the field and just get it yourself?
I would do a lot of field work, and I definitely use like Google Earth a lot, or I would back then. I still do now. But really my big introduction to working with space photography was starting this job a couple of years ago out of college.
Oh, that's a nice first job out of college.
I agree.
So what exactly do you do? How do you work with astronauts in photography specifically?
Yeah, so our group does quite a few things, but our main jobs are to work with the photography photos that astronauts take of Earth. And part of what we do is we run the Crew Earth Observations Payload. And part of that is we have targets around the Earth that we ask the current ISS crew to take pictures of every day. We'll take those photos and send them to requesters and researchers that had asked for them in the first place. We also do disaster response with the photography as well. And another part of what we do is we will train crew members on Earth science topics. basically from the vantage point of the space station. We're not going to get into the nitty-gritty details of minerals and specific rock types, but we'll talk about maybe broad tectonic structures that you might see from space station or climate regions. We cover more than geology. We do cover all earth science topics because not every, most astronauts aren't geologists by training.
Right. But you mentioned that you actually upload requests every day to the station.
Yeah, that's part of what we do. We have a queue of requests, and we'll take into account where the ISS is on a given day, if it's going to be passing over the target area. We look at the weather to make sure it's not too cloudy for a certain region. And then we also take into account whether it's light enough for daytime targets or dark enough for nighttime targets. We have a variety of targets that we like to ask for.
And who are the requesters? Like how many different types of people or organizations?
Yeah, this could be just any principal investigators from around the world. We facilitate these requests through our website, and we screen them, make sure it's something feasible that a astronaut photo could fulfill a purpose for. And then, it's just any researcher around the world could ask for this imagery to be taken.
Wow, that's really cool.
Yeah.
I'm going to start telling all my friends who are researchers so they can do that. So Don, did you train with Andrea or someone in her group before you went?
I trained with people from Andrea's group, and people like Andrea would have the task of uploading instructions for us so that, for example, they may want us to take a picture of an island in the Pacific called Kapinga Marangi. And so then we're flying over that area and we see all these islands, and we'll take 200 or 300 pictures. And then Andrea has the unhappy task of sending us a little message saying, well, you didn't really get the island we wanted, that you took pictures of all these other islands, but you didn't get the one that we wanted. And then we get to do it all over again. And Andrea, I can see you're laughing because I know that happens, because it happened a lot with me where I didn't get the picture of what you guys wanted.
Yeah, and hopefully since then we've improved our operations. I take the feedback of all the crew debriefs we go to. So I've been doing this for a couple of years, and hopefully it's better next time you're on board.
If you have a smallish target, it is incredibly tough to be able to zero in just on that one mountaintop or one crater or one island when you're looking literally at a whole sea of potential targets that all look alike, because you're 240 miles away and they're just little polka dots on the surface of Earth.
Oh, yeah. Some of those targets are really difficult. Some examples of targets could be monitoring how coastlines change over time, looking at how rivers change over time, kind of sediment and erosion. Yeah, here's a nice example of the Aral Sea, where the land is kind of got these like shorelines that trace along the current shoreline. And that's something that we can monitor with astronaut photography, is how water levels in certain lakes change over time, especially lakes that are known for having lots of changes in lake depth and such. So yeah, the Aral Sea is one that's monitored a lot in general. It's basically decreased in size significantly over the past 50 years due to irrigation for agriculture in that area. And this is a very zoomed in shot. I liked this one. I picked it out because it's kind of artsy to me, kind of smooth flowing blues, nice calm colors. But looking at the greater area of the lake, you can see some significant water level changes basically on a yearly basis.
Oh, wow. It looks gorgeous to me because I live in the desert now. And so I would give anything to start seeing huge bodies of water. So Don, you mentioned, taking 200 or 300 photos of a source, which, I mean, I get close, maybe not close to that, but with our iPhones these days, I am a perfectionist. So I'll take at least sometimes 20 pictures of one thing. Andrea, like how many of those, how do you sort through those to figure out like, oh, we got 300 of this thing, but they're not all, they might all be very similar too, right?
Yeah, so on any given week, we might get thousands of Earth obs photos down from station, and we know the very specific times in which we ask for these photos to be taken, and so we'll scan that greater number of photos for ones that fall within a certain time range around that target area, and so that helps slim it down. But yeah, if the astronauts still took 300, we're going to go through that one manually because it is a research product. We want to make sure we are delivering the best frames to the person who asked for it.
Yeah, that's fair, because I also forgot that you take that many, but you're also moving rapidly over a target. Whereas when I'm taking 20, I'm standing there with the target right there. So it's not moving.
And like Don was saying, maybe he takes 300 because the target was really hard to find. These could be small volcanic islands where researchers interested in how vegetation is changing on the slopes over time. Yeah. And you might not be able to pick out the right island from the vantage point of the space station. So taking lots of overlapping photos of an area kind of increases your chances of maybe getting some of those more difficult targets.
Yeah, that's cool. So, but Don, before you got into photography of Earth from space, you've kind of always been a photography geek or a photographer.
Yeah,
since the young age. Is that right?
Sorry. Since I was a little kid, I was taking pictures. My first camera was a Kodak Brownie that used, I think it was 127 or 129 black and white film, and I developed it. And I've been taking pictures ever since.
Did you have your own darkroom then? As a kid?
When I was a kid, but nowadays you have a digital darkroom. Nobody messes with chemicals and bumps around in the dark. You do all your image adjusting on a computer.
Yeah, I miss the darkroom days though. I
do too. There's something visceral about dealing with real film and watching the image develop literally before your eyes.
Don, could you talk a little about maybe some of the difficulties of maybe photographing aurora with a digital electronic camera versus film?
Yes. With film cameras, you take pictures, and the highest sensitivity film we had was ISO 800, which by today's digital standard is fair to middling. And you take the pictures and you don't know how they are going to be until the end of your mission because you can't get them developed until the film comes down to the ground. And that's typically when you come down to the ground. With digital, you get instant feedback and you can iterate on that.
So what's the film camera when you were on shuttle?
The film camera was on my first trip to space station. We
really
had the 70 millimeter full frame cameras, and then we had 35 millimeter cameras, and most of the imagery we took was film. And on that mission was when Columbia happened, and our mission got delayed. We stayed on orbit for an extra 3 or 4 months, and no shuttles flew for 2.5 years. And so the film that we had taken on that mission just sat on orbit and got exposed by galactic cosmic rays. And that was basically the end of film on orbit. And since then, we've done exclusively digital imagery.
So the cosmic rays, did they kind of ruin it entirely?
Cosmic rays would fog it and spoil the background. And we did get my Expedition 6 film back after 2.5 years on orbit. And at this time, NASA had its own film developing capability. And I worked really closely with one of the super techs where he would develop one roll of film. We'd look at it, low contrast, looked bad. We tweaked the chemistry, we tweaked the temperatures, we'd develop another roll of film. And we had hundreds and hundreds of rolls of film. And then we tweaked this, and we finally got it down so we actually were able to recover quite a bit of the initial imagery from Expedition 6.
Oh, wow, that's impressive.
Wow.
Has anyone ever taken a film camera back up into space? Just for artistic purposes?
I don't think so. IMAX flew film cameras for a while, but that would be on shuttle missions where it'd go up and come down on the same mission. And they had the same issue with galactic cosmic rays doing damage to the film.
Yeah. Yeah, space is not a hospitable place.
It is not. And galactic cosmic rays also destroy the silicon-based sensors in our digital still cameras. And after about a year, we exchange all the cameras that we have on orbit with new cameras simply because the sensors are shot full of cosmic rays and the images look awful.
Yeah, you start to see some hot pixels show up on some of the frames. That's something you notice every once in a while.
That's a telltale sign. Andrea, about how many photos does your office manage? Or is there a massive archive?
Yeah, so I guess we run that archive at our website, the Gateway to Astronaut Photography of Earth. We have over 3.5 million astronaut photos of Earth taken since the beginning of NASA's manned spaceflight, Gemini and Mercury missions, all the way to today with what's being taken on space station. And so another part of our job that I didn't mention earlier is maintaining this database so that all of this photography is freely and publicly available for anyone to download and use.
Do you just have a massive room of hard drives or something?
Yeah, there are several servers and backup servers, and it's quite the endeavor.
Yeah, and I guess so. Maybe you haven't been there long enough, but you know how, I'm old enough to know that I used to back up my computer on CDs, and now I back it up on external hard drives. But are we going to have to change that again at some point in the next decade or two?
Well, we do have plenty of backup mechanisms in place for making sure this data isn't lost. It's often double and triple backed up. So yeah, it's many, I don't even know how many terabytes of data, but
yeah,
we've got it all.
Be a good back of the envelope calculation for some students one day.
Yeah, right. I mean, it would change so much with the resolution of photos only getting better with time. And I mean, not only we have 2 versions of the JPEGs of each photo available, and we have raw camera files as well. And so it really is a vast amount of data that we organize in different ways to hopefully make what you're trying to find, some sort of specific photo, hopefully you can find it in our database.
Right. That's a challenge for everyone out there. Dawn, having been just such an avid photographer growing up, did you have what was it like the first time that you turned your camera in space back to the Earth? Was that kind of an interesting moment?
Yeah, space offers a unique environment. The lighting is different down than what we're used to on Earth. It's not buffered by the atmosphere. The exposure meters don't work the same way, and you have to manually adjust the camera in many instances to get a good picture. The basic rules of artful composition all apply in space. And for example, let's look at the windows that we have available to even take pictures of. There's a cupola, and there should be a picture of that from the outside so folks can see what the cupola looks like. And it's this amazing collection of 7 windows that are arranged in a hemisphere, and it looks down at Earth. Oh, there's the picture. Yeah, so you can see
in the middle.
Covers open, and it's a little bubble. It's the best that we can have as a bubble right now because there's a framework around the windows. And then from the inside looking at Earth is just amazing when you're in this cupola, and there's I like that. That's a Mother Earth, I like to call it. But then there's another picture inside the cupola that shows all the camera equipment that we have.
Yeah.
There it is. And I like to challenge people to count how many cameras are available there. Earth moves by really quickly, and you need the camera set up for every possible thing. I think there's 7 cameras in there. Yeah. We've got a lot of cameras.
Yeah, and not to cut. Oh, sorry, Don. I was going to say something that makes astronaut photography unique is that they have a variety of lens sizes to choose from as well. So anything from like a fisheye lens to a really big like 800 millimeter lens to get some of those highly zoomed shots. It creates quite the variety of shots that crew members like Don can take from space station.
Yeah.
And you have to remember, most art, on Earth or in space, is not just haphazardly done. You need to have an approach. You need to have a plan. And when I launch into space, I have an approach and I have a plan for what I want to do with my photography. I don't just show up on space station, look at the window and go, oh, isn't that neat? Let me take a picture. I've got pre-laid plans for different artful things that I want to do when I get on orbit. And I've already pre-flighted the cameras in training, so I know how to set the cameras up to get the imagery that I want to do.
Oh, wow. So I think we have some of your photos from space. Are there any
trails are an example of that? These are basically 30-minute time exposures that show amazing detail from a physics point of view. Just from the physics, I can talk for at least a half hour about any one of these pictures. And oops, I don't have my watch on because I don't need a watch anymore because I'm working from home. But if I did have a watch on, I could time myself and talk for 20 minutes just on this one picture, and I won't subject everyone to do that, to doing that. But what I do like about these pictures is that they have an artful measure to them. They look strange. They don't look like the standard planet Earth. It's like, what's going on here? And I like that. Oh, this is what I call it, ghost panel, because in the course of the time exposure, the solar panels moved through and made this blurry streak.
Oh.
And this kind of photography is all pre-planned, and the specific compositions weren't, but I knew how to run the cameras. I knew what I wanted to do, and I'd worked that out way before I even launched on this last flight.
That's beautiful.
Yeah.
Wow. What are some of your favorite? Oh,
I call that lightning bugs.
Yeah.
It shows a time history of a single lightning storm. So a lightning burst will go flash, right, and then there's orbital motion, and then it goes flash again, and then the streaks of city lights moving by. And some of these storms are really, really active. And if you look closely in some of these images, you can see sprites and other forms of upward directed lightning.
Ooh. Yeah, and that's a perspective that no one else gets of lightning. I mean, even if you're at 35,000 and you sometimes get to see some, it's usually like way off in the distance.
Yeah,
but from above.
One of the artful aspects of being in orbit is that you can see structure on Earth on the length scale of half a continent. If you're over the middle of the United States, you can't quite see the east and the west coast at the same time, but you can see about half the North American continent when you are going over it. And this allows you to see detail that you can't see from airplanes and things. There's a shot of von Karman vortices coming off the Aleutian chain in Alaska that I bet will show up here magically in just a moment.
I'm looking for that one. There was vortices on the island chain?
Yes. Let's see. What did I call that one? I think I called it von Karman.
Yeah, I don't have that one here.
Yeah, to go off what Don is saying, the altitude that the ISS orbits at, looking at the cupola, looking towards the horizon, you've typically got 1,000 miles towards the horizon that you can see.
Oh, wow.
Hey, John, I have one called the Bahamas, because that also illustrates the same thing.
That's a pretty long distance to see.
There.
Okay, there. You see, we're over the Bahamas, and you can see all the way from the Bahamas. You can see Key West. You can see Florida. You can go all the way up into Georgia, and then you get to see the atmosphere on edge. So there's an artistic measure of having this kind of perspective that you can't get when you are on Earth. And one of the aspects of my photography as an art form is to try to record these kinds of compositions that show what's going on in space, perspective of looking back at Earth.
Right. Nice.
Yeah, the blues of the Caribbean are just gorgeous from this perspective. And you know, there's deeper water where the blues are darker, shallower water where the blues are kind of a lighter blue near the islands. There's a lot that could be interpreted from photos that are also beautiful.
Yeah, Andrea, you sent us some of your like favorite Earth imagery photos. What's a good one that you like, both for like the artistic composition, but also like can teach some science or record some science?
Yeah, I have an example of Lake Van in Turkey. I think to me it's a very artistic photo. I love the blues and the swirls in the water. And then you can kind of drill in. You're like, well, why are those swirls there? You could look into whether it's sediment flowing or algal blooms or sort of plankton blooms or such. It just depends on the body of water. But this one's always kind of stuck with me just because I really enjoy the different shades of blues and the swirls, and then the kind of stark contrast with the rough landscape around it.
Hey, Andre, I see an elephant in that picture. Do you see the elephant?
I see that now.
Yeah, isn't that amazing? There's an elephant in the picture. Wow.
Very helpful.
Oh man, one of my coworkers is always basically picking out animal shapes from astronaut photos, and she sends them to me all the time, and it cracks me up. I actually haven't seen the elephant in this one before. I think I was too focused on the water.
Yeah, like fluid dynamics for me is something that is just so cool and so visual. So even like what you were saying, Don, I imagine those vortices that you were talking about off the islands, and just watching water and its effects, or anything, because the atmosphere acts like a fluid too, but it's just so gorgeous.
Yeah, y'all,
Another
I have to bring
example of different watercolors could be at the Patagonia lakes. There's lots of huge glaciers down on the southern tip of South America, and just coming off of these glacial fields are big, beautiful lakes that are like jewel toned, different shades of greens and blues. And I'm waiting for it to pop up so I can talk about it more.
I'm looking for glaciers or something. I don't.
Patagonia glacial lakes.
I don't have a Patagonia in here.
Okay.
Yeah.
Never mind.
I have to bring up this one though.
Okay.
Oh, that's one of my favorites.
I like structure.
I call this Godzilla in space. Yeah, the neat thing is that shadow is on the Japanese module, and you can see the Japanese flag. And anyway, and it's the shadow cast by the Canada arm with this special dexterous manipulator put on the end of the arm. And anyway, I really like the starkness of the light and the dark and the shadows, and then just a little bit of color remained in the photo that showed the Japanese flag.
Yeah, and I don't see a lot of photos like this because my group specifically works with the Earth photography. So seeing pictures like this is a treat to me as well, because these are views of station I don't look at very often.
Well, one thing that did happen after Columbia, when film was no longer flown, we lost the ability to do color infrared imagery of Earth because that was all film based. And on my last flight, I got NASA to take a brand new camera and pull the infrared blocking filter off it so that we were able to once again do color near infrared imagery of Earth. And John, if you could pull up the Ganges River Delta in color infrared. It's the big magenta one.
Got it.
Yeah.
Yeah. And you see, not only does this show a lot of scientific related information, but I think these kinds of images are just amazingly beautiful.
That's stunning. Yeah, I could look at river deltas all day, for sure. But even in other wavelengths is even cooler.
Yeah. Yeah, another river that catches a lot of, or gets photographed a lot, is the Betsuboka River in Madagascar, because of its just brilliant red colored waters. And yeah, this picture is just gorgeous. This kind of complex braided delta. I've read astronaut interviews saying it looks like the whole river is just bleeding into the sea where it is, because sometimes the river is so sediment rich with red sediment.
It is, and one of the things I've started to do strictly for artistic measure is to take these images that have intense saturated colors, like the Betsuboka River Delta, and then I cast them in black and white. And
Yeah.
there's an image of the Betsuboka River Delta, not the main braided channels, but off to the side. And when you take a picture like this, it's normally just brilliant colors, and make it black and white, your eye goes to different details. And John, pull up the black and white version of Mother Earth.
The blue marble?
Yeah, the blue. There's the blue marble color, and then and cycle it back and forth. Show the color version of that. Yeah, so there's the color version, which is the classic way of seeing it. But then I stripped out the color and made it black and white and flip back. Yeah, this is actually my favorite version of Mother Earth is this imagery in black and white. So I'm going through a lot of my images now strictly for the artistic measure and stripping out the color just to see what it does to my eye and what features I seem to get drawn to.
I like that. So Don, you're talking to us from your garage right now, but if we went inside your house, is it covered with space photos on every wall?
Not really. You know, when you have all of these photos and everything, it almost gets ho hum. And so I'll put the photos up on the wall where we have a big spot of plaster that fell off or something like that. To cover the wall damage, but normally we don't have a lot of these pictures up in the house.
If you've got 3.5 million astronaut photos, how many of those do you think you took, Don?
Oh, well, I do know our crew. When I flew, we didn't attribute photos to any individual, and so they all went into one big bin. And during my last mission, our crew, 6 people, took over 500,000 pictures. And on Expedition 6, we took about 55,000 pictures. And then on my shuttle flight, STS-126, we took about 35,000 pictures. So I need to have a big hard drive. I've got a 40 terabyte hard drive in my office just to hold copies of my pictures.
That's a significant fraction of 3.5 million.
It is, yeah. Wow. Thank you.
Oh, actually, one time, this was on my last mission, I took a picture of a little yellow sticky tab on my computer screen, and I said, I bet you are not really looking at all of these pictures. And one of the image processors down at JSC sent me up a picture of her next to her computer looking at the picture that I had. I bet you're not looking at these pictures.
Just trying to see if you were paying attention.
That's too funny.
Yeah, so somebody looks at every single one of these pictures.
Mm-hmm.
I mean, that would be, I know it'd probably get tedious after a while, but it sounds like a fun job to me. Like I would volunteer as tribute if anybody needed help.
Oh, to look at the pictures, yeah. Andrea has an amazing job, maybe even better than mine.
No, I don't know.
You guys should do like a job swap, like one of those TV shows or whatever.
Oh, now I see John has pulled up a picture. One of the things I like to do is take self-portraits. And I would
I wanted to talk about those.
Yeah, I would try to take a self-portrait where maybe I wasn't really in the picture except in a little reflection off of a shiny piece of metal or something like that. And this is a picture that I took intentionally to show that in a weightless environment, you are in all different attitudes. And most pictures of most astronauts almost look indistinguishable from being on Earth, and that you're upright and everything else is upright and we're all upright together. And that's not the way we really live and work in space. And we can be at all different angles to each other. And so I tried to take a number of self-portraits where I would be like popping in out of a hatch, like in this picture.
Nice. So before we run out of time, I want to talk about the cupola, like self-portrait that you took, because I think it also, we talked about how cool the cupola is, but there, you were mentioning when we sort of had the pre-talk about all of the different technical difficulties in the cupola too, because there's like multiple panes of glass. And so you're probably having a ton of refraction going on and reflection. And,
yeah,
and
we have
day and night.
Yeah, the windows have 4 panes, and that means 8 surfaces. And NASA's really good. They have anti-reflection coatings on these surfaces, but even if you can get it down with a broad spectrum anti-reflection coating, maybe down to 2%, you have 8 surfaces, each with 2% reflection. And then if you get any stray light coming in, it just ruins the artistic composition of a picture to have all this stray light. And this picture is an example where I thought, let me live with the reflections. And I intentionally took this picture at nighttime with a little flashlight shining on my face. And I call this the 7 faces of Dr. Dawn. And each of the windows has a little distorted version of my face, and along with seeing a nighttime version of Earth underneath. So even though you do not like the window reflections and you have to work really hard to minimize them, sometimes you can use them to your advantage.
I feel like this is the movie poster for like a new sci-fi dystopian film or something.
Yeah, you could have a person looking out the window, and then as the aliens coming up behind him, you see 7 reflections of the alien coming up to the person.
Yeah,
that'd be a good sci-fi movie.
I would watch that. Do those panes actually pose a hurdle during the daytime too? Like if you're trying to, looking at an angle, but you're going through so many different.
Yeah, if you have a shaft of sunlight going through one window pane and then reflecting off of another, they make really, really strong reflections, and you'll see 8 reflections superimposed in your imagery. And I didn't send you guys any of those for display, but there's literally thousands of pictures like that. I'm sure Andrea can talk about pictures that are spoiled by internal and external reflections.
That could be a cool gallery in itself, actually.
Maybe.
It could. It's kind of like you can make a gallery out of all the blooper pictures.
Right. Yeah.
John, do you have one of the pictures of a shroud covering over one of the windows? This is kind of a behind-the-scenes picture.
Shroud covering.
Yeah. So Is that like, do they have, each window have its own shroud that you could potentially put on?
They're like a conical piece of fabric that the large outer edge seals around the inner edge of the window, and the small cone-shaped point has an opening that you can put the lens of the camera in. And that way it excludes all ambient light, and you can get rid of the reflections.
Right, and it's kind of like on DSLRs here, any camera, when you have those, I don't even know the proper name for them, that it's at the end of the lens.
The lens shades, yes.
Yeah. Okay, I was picturing more like let's block out all the side windows so we don't have any stray light and look through the first one. But that's even cooler, actually. So it's like the old photographers, you know, putting the
actually it is like that.
Yeah, I don't see any that have like a shroud covering the camera as it looks out the window. I don't think I have a photo like that here.
That's okay.
Yeah, or I'm trying to squint down to find them, but.
So, Andrea, getting back to your art or space and Earth-inspired art, do you have any of your stained glass handy?
Yeah, since we had talked about it before, I grabbed one of my favorite pieces that I made. I have it over here. But yeah, so I started doing stained glass just on my own time last year, and I've made this. Well, I don't know if you can hear me. Yeah, I've made this geologically inspired piece of stained glass art where you're looking at like a cross section, looking down into the earth, and then you've got faults and layers of rocks that have been kind of folded, kind of similar to how they would be in the real world for certain tectonic settings. And so I pulled that inspiration from lots of my geology classes over the years. We would go out to places like Montana and Wyoming and map geologic features in that area. And I've been an artist my whole life, and so this is kind of a new medium I've taken on, and I'll make.
Yeah, that's what I was going to ask. Like, what drew you to stained glass, or?
Well, stained glass is just beautiful to look at, and I didn't know anyone that did it, and I wanted to try something new and unique that interested me. I've been a painter my whole life, and so I wanted to kind of jump into a new medium.
Very cool.
Yeah.
Don, are you jumping into any new mediums?
No, the same old mediums of photography. I love to write poetry. I'm kind of a closet poet, and I've got a lot of space related or space motivated poetry, and then just goofing around, making stuff at home. I'm a maker, so I make stuff.
Yeah. Do you have any of those photos of some salt flats that we could show? Because to me, some of those almost look like stained glass on Earth. Some certain salt flats and evaporation ponds can be very colorful. Yeah, this is one of my favorite examples of, this small salt flat over in Western Australia, where, the rectangle in the middle is, man-made. People let water in, it evaporates, they harvest the salt, and then there's all sorts of causeways that kind of block the water and the land around it, and it creates a lot of different kind of beautiful colors in the water. And so I tend to pick out colorful photos, so I thought it was interesting to hear Dawn's perspective on liking black and white photography from space, because I guess I'm not there yet. I'm still very much into my colorful photos.
This is just a tiny tangent, but Dawn, with your love of black and white, does that mean, were you as taken as I was with the Cassini images, especially the really stark kind of black and white ones?
I love the Cassini images, and seeing Saturn's rings in black and white, and actually seeing what looked like little snowballs accumulating in the rings, I found just amazing. And then the shadows cast by these small asteroids, large meteorites, ice balls that are accumulating in the rings, and they will cast stark shadows across the other rings. And seeing these in black and white, I found were just amazingly beautiful.
Yeah, yeah, me too. So I also want to ask both of you, I mean, we talked about some of the things that you like to photograph, but are there types of places on Earth? I mean, we sort of might have covered this, but landscapes that especially draw you, that are like, if you had your druthers, this is all you would take photographs of.
Andrea, you go first.
All right. I mean, I love all of the photography. There's just such a variety. But I guess if I were to pick, I really like kind of like the dunes of Namibia. It's almost like a color blocking photo. If you've got like the water and then, this photo's kind of split into threes with these beautiful red dunes on one side, more of a less dune-like area on the other, some rivers running through it. And then a little bit of sediment in the water, some clouds on the corner. But I really enjoy pictures of coastlines because I like kind of the stark contrast between whatever colors the land might be artistically and the colors of the water as well, since it can just vary so much around the world.
Yeah, and even in the red part of the desert, those kind of look like dunes or, like waves of sand or dirt created by, I guess, the wind.
Yeah, those are different sand dunes. It's some of the largest sand dunes on Earth in the Namib Desert, and then those little spits coming off the coast are certain wetlands where like migratory birds will go. And so more than just a pretty picture, there's something going on the surface in each photo that's being taken.
Yeah, that's actually just a really cool thing to think about because you have such a distant perspective. But then if you think about what is happening on the ground in each of these areas in the photograph, it can just be universes almost.
Yeah.
All right, Don.
Okay, I like to take pictures at night. I'm an amateur astronomer, and I have a whole host of tools that I use for taking, sweeping landscape pictures at nighttime that show the nighttime sky. So that's one of my favorites. And then I like to see the world through a fisheye lens. And this is a special lens that gives you extreme wide angle views and it gives distortion. And I like to take a fisheye lens and take pictures where people may not necessarily think that it was taken with a fisheye. John, why don't you pull up the picture of my business suit?
Got it.
And see, I like this. This is a black and white.
Yeah.
It's taken on space station. It was taken with a fisheye lens, and I intentionally composed it so that you can't necessarily tell it was taken with a fisheye lens, partly because a fisheye lens makes everything kind of circular, and this was in the airlock, which is all circular structures. So the circular distortion of circular structures, it all looks normal. And then I like the creamy color of the whites in this picture. And this picture took 3 fill-in flashes because the fisheye lens had such a wide angle field of view. I had 1 flash on the camera and 2 slave flashes, all strategically put dialed back for just fill-in flash so you won't make harsh illumination. And this picture probably took me an hour and a half to set up, compose, and I probably took 500 pictures, and then you choose 1 picture. And this is something that I would do like on a Sunday morning when almost everybody else would be asleep. And what do you do on a Sunday morning on space station when you have a off-duty day? And so I would set up and take pictures like this.
That's so cool. Have you gone out and photographed the comet?
I have been out 5 times now to photograph the comet. This is Comet Neowise. and it has been cloudy every single time. It's been clear like overhead, but near the horizon where you have to see this comet where it rises shortly
Right.
before the sun comes up. And not only is the comet still fairly faint, there's a lot of background light pollution in the Houston area, unfortunately. And I just have not gotten a good picture of Comet Neowise. I've seen other people that happen to be in the right place at the right time here in the Houston area, and they've gotten amazingly good pictures considering the environment of Neowise.
That's not from Houston.
And then there was this great one from the station.
Well, this is a picture Dan Burbank and I made right at the beginning of Expedition 30, and this is Comet Lovejoy, and this is actually composed to be artful, and it's a stacked image with light and all taken at the similar moment, but stacked images to show the lightning storms on Earth and the atmosphere on edge with the rising sun, and then Comet Lovejoy.
So when I used to run public stargazing nights, we had clouds or something that would cancel the stargazing portion. I would just tell everybody that they're officially honorary astronomers, because if you've been foiled by the weather or the clouds, you know what it's like to be an astronomer.
Yeah, we don't have to worry too much about clouds spoiling our view from orbit. In fact, the clouds are part of the view.
Yeah, they really are.
Yeah, this is a picture of the sun about to rise. Do you have the sunset photo we could share?
Yes.
Yeah.
Are those just clouds formation that's in front of that with the darkness?
I believe so.
Sure.
I'm not for certain, but this is kind of one of those views that as the space station orbits around Earth, the crew members have opportunities to see sunrises and sunsets 16 times every 24-hour periods, more or less. And so Don could talk more about this. You get views like this fairly often.
One thing, for the sun to set on Earth, it takes about 2 minutes. The disk of the sun goes below the horizon in 7.5 seconds on orbit because of your orbital velocity. And so you have to be ready for that picture. And John, switch to that other cupola picture that showed the sunset.
Got it.
Yeah. For this picture, in order to catch that flash, you have 7.5 seconds. And so you got to have your act together, which is one of the reasons why you have all of those cameras in the cupola. Because if you even have to stop to turn a camera on, or, what's the f-stop, what's, adjust it, you've missed your target. You have to be all ready to go. And oftentimes you put it on continuous high, and you might take 30 pictures in that 7.5 second window just so that you can get the El Primo sunset picture.
Right. Yeah. So who submitted that picture before, the one that was the first sunset photo?
That was one I found.
Yeah. Because
go ahead.
I was thinking that this is like an aurora photo. It's upside down, but it's actually like Earth and an aurora. But now I want that photo on a scarf.
Oh yeah, that would be beautiful, really.
So
those interesting shots where you've got like the whole horizon taking up with the sunset, those can be taken with some pretty large camera lenses. And so I've always found it interesting where you can take a very large camera lens, which would zoom in a lot and get some more detailed on the ground, or you can shoot it through the atmosphere and get interesting cloud and atmospheric structures that you can take pictures of as well.
Yeah. I could keep asking you guys questions for hours, but I think I need to give other people a chance to ask questions. Okay. So, Josh, you got some piling up for you?
I do. While y'all were doing the discussion about the pictures and stuff like that. And by the way, I was getting a little bit too excited. I was like, oh, I gotta show this picture. So I would just push a picture at y'all and make you talk about it. Thank y'all for bearing with me, because I have an entire set of folders over here of all the cool pictures, and I wanted to show so many of them. I was probably jumping the gun a little bit there. So thank you for bearing with me. But yes, while y'all were having the discussion there, we were actually taking some questions from chat. So now we have a little bit of time to go through the Q&A. Y'all want to do that?
Sure.
One of these days I'm going to ask y'all want to do that as like a segue, and somebody's going to say no, and I'm not going to know what to do. It's like, yes, the next part of the show is Q&A. Why are you asking if the guests want to do it? We already know we're supposed to be doing it. So let's do that. Let's hop through some of the Q&A here, and I'm going to take questions from our chat queue. Thank y'all for submitting all those good questions. If you have a question that comes up over the course of the discussion here for the next 30 minutes, you can submit it to the queue. If you start your chat line with the word question, it'll go into a little software interface here, and if we have time, we almost always run out of time, we'll get to the questions. So without further ado, let's hop on over and do a little bit of Q&A. Sound good?
Let's go.
All right. So let's see. Just go over that way. There's a lot of questions about the cameras that you are using, right? And so this is Don, Andrea, just whoever has the answer, sort of hop in. If it's specific to a person, I'll address somebody specifically. But are the cameras that you see on the space station, are those NASA's cameras? Do they just stay up there permanently? Do the astronauts take their own cameras sometimes? Do they shuffle out cameras as they need to be repaired or replaced or something? How does that work? I guess let's start with Don on that one.
We use Nikon cameras on space station, and we always stay up to date with the state-of-the-art full professional camera. So currently, we're using D5s, and I think we're going to move to D6s when they become available.
Gotcha.
And we have a whole selection of Nikon lenses from 8mm fisheyes to, 1,200 millimeter telephoto lenses.
Wow.
And so that's the camera systems that we use on station. And like I said before, the cosmic rays will basically make the camera almost useless from a artistic recording point of view.
Right.
It's still okay for engineering, but they get shot full of cosmic ray damage. You have all these bright colored pixels and bright white pixels, and they're really hard to get rid of the cosmic ray damage without dumbing down the fine detail. And so we replace the cameras about once a year.
Okay, gotcha. And so, Andrea, in terms of cameras taking cosmic ray damage over time, do you have like an algorithm that looks for or tries to identify or repair that in the images? Or do the astronauts say, hey, this camera's got hot pixels at these locations that we can't fix anymore? Is there any sort of communication between space and the ground as you're managing all those photos?
Yeah, there is communication for, I guess, this specific issue is not with my group. It's with a different group that actually trains the crew on how to use the cameras and the maintenance and upkeep. And so, yeah, that's just a different group here at Johnson Space Center.
Gotcha. And when you get the picture, is there any sort of processing you have to do to try and remove those things? Do you just leave them as they come? Does it ever cause a problem with looking at the pictures? Like, oh, we can't get data out of this because there's a hot pixel. I wouldn't guess there would be.
No, I mean, the photos are still useful. You can always, I guess, omit the pixel if you need to.
Gotcha. So that sort of leads me to another question, and we have a lot of questions to go through. What do you do?
Has a question though.
What do you do with the pictures that aren't any good? So it's sort of weird to say the pictures that aren't any good, but like my daughter has 23,000 pictures on her camera because she never cleans off her memory card, right? And do you clean out the pictures that were out of focus or just accidental shots? Like, how do you do that? And we'll ask Don next, but Andrea, what do you do with extra pictures?
We keep them all. They're all on our database. There's nothing that's really discarded.
So there may be like an accidental picture of an astronaut, like the side of their face, like.
Yeah, I mean, our specific database works with just the Earth shots, and so pictures with crew members in it get screened out for different groups.
Gotcha. And Don, go
One
ahead.
thing about NASA cataloging every single picture that's taken, you never know when there might be useful information in it, even if it's a bad picture. And say you were fiddling with the camera and you accidentally took a picture of your foot.
Yep.
Well, maybe in the background there might be some computer box or power supply, and then they later found, hey, we were having trouble with power supplies. On that power supply there could be LED lights. They go back to that awful picture of your foot, and they can look and go, oh wow, now we know that power supply was working because we saw it in this picture. So you never know when you live in a complex machine like the space station, when a blurry or ill composed picture might be useful at some future date.
So it's like there's no bad pictures on the space station.
Oh, there's lots of bad pictures, and I've taken more of them than anybody else.
So that's another great question here. When you're taking photographs from the space station, is there a policy against hitting the delete button? Like, do your Nikon cameras have the delete button deleted or removed or something? Or do you ever go through and say, oh wow, that's not what I was looking for, get rid of it? You just keep everything.
We are taught to keep everything.
Gotcha. It's a very diplomatic answer. I like it. So another question about cameras on the space station. We know that the space station has to be really, really careful with the different materials that are there, like flammable materials, things that can break down and get in your eyes or in the air vents or something. The cameras have a lot of glass, and I know it's really hard to break a lens, but is there anything about the cameras that you have to keep special track of that maybe we don't think about on the ground?
Not really. The cameras all have batteries. There's probably more safety concern with lithium-ion batteries and getting a thermal runaway.
Right.
And NASA goes through a lot of testing for any kind of rechargeable lithium-ion battery that goes on station, because that's bad news if those things go off.
Right.
The lenses, anything out of glass typically has to be coated with tape or something like that. We have clear protectors that go over the displays for our notebook computers and things like that, so that if the glass were to be broken, it would be contained. And I think there's a general exception for camera lenses simply because they're very robust, and if you put a piece of tacky plastic over the lens, you wouldn't be able to take a picture.
Yeah, exactly. I mean, that makes sense. If you do something and you actually shatter a camera lens while you're on station, you're probably doing something wrong.
Yeah, I agree.
There's a bigger problem to be addressed, right? So here's another one about how some of the people watching can access a bunch of these photos. So sort of two-part question here. Andrea, I know that we had a website where a lot of the ground pictures were being available to the public, I guess?
Yeah.
What is that?
I saw the link on kind of the Intrepid page.
Right.
In the Kerbal Space page, but I guess I'll just say the URL, even though it's on those links.
Is it the EOL JSC?
Yeah,
got it.
eol.jsc.nasa.gov. That's the website that my group runs, the Gateway to Astronaut Photography of Earth.
Cool. I just spammed that into chat. So if you're interested in seeing a lot more of the images, there's like some odd million pictures there or something.
Yeah, over 3.5 million and counting every day.
So if you need something to binge scroll through while you're stuck at home in quarantine or whatever, the 3.4 million pictures should last you a little while.
Yeah. I would also, John, like to point out that every picture that an astronaut takes is automatically in the public domain, and people can use it without charge. And this is one of the neat aspects about NASA, is that all this imagery is public domain and freely available to the public. I will also caution that what you see from the imagery database are raw images.
Okay.
And the images that you saw that I had, I probably spent 3 or 4 days with every one of the images that we've shown on this program, personally tweaking on them and making them look the way that I want with my artistic perspective. And so everybody's welcome to go to the database and get the raw files and make their own prints.
Right.
My feeling is it's like if I had access to an Ansel Adam negative and I made a print, would it still be an Ansel Adams?
Right.
Right.
So that was actually the second part of the question. Don, do you have a website where you have some of your favorite photos or something like that? Or is there some way that people can find that sort of stuff?
When I go do presentations like this,
right,
oftentimes there will be websites where they take some of the imagery, and there are some websites around. Portraits of a Planet has been used in some of these websites. I do not run any of these websites or do anything with them simply because I work for NASA and
you're kind of busy.
But other people can take my imagery, like after I give a talk or something, and they could go ahead and post it as some kind of a gallery show.
Gotcha. Okay, good deal. And then again, y'all, I just spammed that link into chat. If you're looking for that raw image database, you can click on that after the show. Like, wait till the show's done and then click on it and go get lost in 3-point-something million images. Right? Let's see here. Here's a good one, and it's concerning when you're in space taking photographs, how much of it points down at the ground and how much of it looks outwards to the stars. So is there a lot of astrophotography that happens in space out on the station? And that actually came from one of our photographer friends, Bill Nash. So Bill, thank you for that question.
Most astronauts take pictures looking at Earth because it's the brightest, most beautiful object that's right there in front of your window. Doing astrophotography pictures from space station takes a little bit of skill, and it's something that takes some pre-planning and in order to do a good run of it. And then most of the windows that we have on station have views that look down on Earth, and so you have to find some sort of special windows that don't necessarily look straight down at Earth, and you have to set up and use those windows if you want to do astrophotography.
Right. So the way the space station flies, it always has the cupola sort of pointing down at Earth, and the cupola never flips over and looks out to the stars or whatever.
Correct. There may be rare occasions where they're doing orbital maneuvers.
Right.
And if you are a savvy crew member and you know that there's going to be an orbital maneuver, that's when you set up to do some of your astrophotography.
They're like desaturating the control moment gyros or something like that, and now I can run over and...
Or with visiting vehicles, oftentimes they have to get into a special attitude, and during these special attitudes you can get different views out the standard windows.
Gotcha. All right. That's something I hadn't even thought about. I mean, there's windows on the space station, but it's not like sci-fi space stations where you can windows in every direction. Like the cupola is sort of the big window, and everything else is sort of a small little... Gotcha. Here's one. Godzilla, thank you very much. We actually had your picture in the stream earlier today. Andrea mentioned sending photo requests to the astronauts on the ISS. So are we seeing a shift of jobs here where there are smaller camera satellites that are able to take the pictures that you would look for, and we don't need a human or an astronaut to be in the loop anymore? So do we see a shift recently, I guess, to summarize, in these small little satellites taking photographs of things you want as opposed to needing a human up there doing it?
So I can't speak to small like CubeSat satellites, but NASA's got a variety of Earth orbiting satellites that take images of the Earth, whether it's in visible light or other wavelengths. And so there's advantages to both. And one of the advantages to human photography is that they can respond on the fly to events as the space station's going over, whereas certain satellites have kind of a set temporal resolution where they'll see the same place every so often. And it's going to take an image no matter what. Whereas we could, send a message up to the crew members saying, hey, that space station will be at this location at this time, and we know there's a volcano erupting. Can you get pictures of that for us? And
that's cool.
That's one of the advantages. And then, there's just a lot of advantages. Having the different lens sizes, so you get different zoom levels and different resolutions to photos. You've got that human aspect that makes it truly unique.
Yeah. And especially when
Let me
yeah.
jump in just a minute on that. The satellites typically have orbits designed so that when they take their imagery, it's local noon time, so that there aren't any shadows.
Gotcha.
And it's the shadows, the contrast, the lighting that gives things an artistic view. And I didn't send you these pictures, but I've got 2 pictures of this obscure place. I don't know whether you've ever heard of it. It's called Manhattan Island. I don't know if anybody there know what that is. But anyway, I've got these 2 pictures of Manhattan. One picture I took from Google Earth.
Right.
It's exactly like that. I mean, no shadows. You see all the buildings standing up, not a single shadow.
Yep.
And then the other picture was taken by one of my colleagues on Expedition 30, and it has low angle sun, and you see the shadows. It almost looks like there's a sundial built into the skyline of New York City, and the shadows get projected over the East River, and it's just an amazing dimension, and it's the difference between art and machine gathered scientific data.
Yeah. That's exactly the comment I was going to make. Is I don't want to remove the astronauts from the equation. I want more people, like we talk about space tourism and stuff like that. I'd love more people going into space and taking this artistic eye, like how they see what they experience when they're up there. Because the as many satellites as we could put in orbit with as many cameras as we could slap onto them, I don't think it's quite the same as having a human being there saying, "Wow, look at that! How do I capture this? How do I share this?" You know. I get you completely there. You can wave me off on this one because I don't actually understand the question. But a barn door tracker, an ISS barn door tracker. Does that ring any bells for you, Don?
Yeah, that rings a bell.
Okay. How long did it take, Don, to build the ISS barn door tracker?
Okay, it probably took 2 weeks of my off-duty time. And we don't have a lot of off-duty time. We work 12-hour days. And we typically, I should say, we're scheduled for 12 hours a day, and we typically work 13 to 14 hours a day. And we work half a day on Saturday, and then we typically get Sunday off. So we're not up there to eat bonbons and sip tea. We're up there to work, but we do have off-duty time. And it probably took me about 2 weeks of my off-duty time to build the barn door tracker, which is basically a poor man's version of a tracking system that amateur astronomers use this to counteract Earth rotation. So that you can, when you're on Earth, you can take pictures of space. But I made the exact same thing so that in space, I can counteract orbital motion and take pictures of Earth.
See, I Googled barn door tracker real quick to make sure it wasn't some inappropriate joke or something. And I'm like, okay, it looks like a camera mount. That's probably something I can ask out loud. But I had never heard of that before. It's something, does it move the camera or does...
Yeah, what you do, you have 2 pieces of plywood with like a piano hinge.
Okay.
And then you have a bolt going through, and you have to know what the thread pitch is. And then you calculate, okay, with a stopwatch, you calculate, okay, I turn that bolt a quarter of a turn every 13 seconds. And that will hinge the board at the rate Earth rotates. And then you line it up correctly, put your camera on there, and you just sit there with a stopwatch, and you just turn the bolt a quarter of a turn every 13 seconds or whatever the pitch rate says. And now you can take a long time exposure of space, and
something's moving.
It's very simple, and it's as simple as a barn door.
Gotcha. I'd never heard of that before, and the reason I love doing these events is because I learn something every single time. I always joke I like to surround myself with people smarter than me, and that's easy to do when you all dial in. Let me see, there's just a couple more questions here. Here's one for Andrea. Andrea, how big of a jump was it going from your previous work as a geoscientist to training astronauts and combining your love of science and art? Like, was that a big jump? How do you transition between those two things?
Well, I still do geoscience on a regular basis,
right?
And I guess it was just a natural career progression. I joined the group, kind of learned the ropes, and then discovered, I'm comfortable talking to the public, to crew members, and that's and then I was entrusted with that responsibility. And so it just comes with time and experience.
Gotcha.
So not really a jump, just a gradual.
Just you sort of stepped into it over time, I guess.
Yeah.
Gotcha. Let's see here. Here's a good one. This is which emotions, probably for Don, which emotions do you try to capture when taking photos in space? Awe is a normal emotion that's captured. Do you try to capture more? Because we all know these photos of the Earth, they're so awe-inspiring, but what other emotions do you experience?
Ooh. A lot of times I just try to capture what seems to be going on at that moment. And Andrea, what kinds of emotions do you think have been captured in the Earth Ops pictures that you see?
Well, I guess I could talk about sometimes when we collect disaster imagery, we're collecting it for a purpose because there's some sort of, natural or man-made event, like maybe a wildfire or flooding going on in a certain area. And so you feel this sense of responsibility to make sure that you're directing the crew to take the correct photography, because ultimately we could process that photography and get it to people that are using it for whatever they need in that first response.
Right,
Not
response
first
or assessment or...
Yeah. Post-assessment of disasters and such. So yeah, we take that seriously. It's probably one of the most important parts of our job is our disaster response.
Right. And I almost wonder, just personally, we've seen a lot of imagery from disasters, floods, hurricanes, fires on the ground, and I wonder if you look down from space on something like that, does it sort of remove you from it? Does it seem like it's not so bad, look, or does it give you a sense of scale that, wow, that's a lot of flooding or that's a lot of fire? Looking at those, Andrea, do you sort of feel removed, or do you feel like you have a sense of scale?
You definitely have a sense of scale, especially if you're comparing it to imagery where there's not a dynamic event happening at the same time.
Right.
Living in the Houston area, we're pretty accustomed to flood events, and so when I see it happening in other places, I understand the threats behind that and the hazard.
Right.
And then you see pictures of like wildfires over California, and you hear on the news of people having to evacuate or fires spreading, and then you can see it in some of the photography, and it's all connected.
Yeah.
So no, I don't feel I guess removed from it.
Gotcha. That's sort of a heavy topic to talk about, right? When we're talking about disasters, because we know people get affected by things on the ground, but being able to image them from space definitely gives us a little bit more information for us. That's what it's about, gathering information so we can make decisions.
And I didn't include any of those on this because they're not particularly artistic to me, more because they have a different purpose they serve.
Gotcha. A little bit of trivia just really quickly. We are just about to the end of our time here, but in terms of trivia, in the database that you have, do you know what the oldest NASA photo is? So how far do they go back?
We've got Earth Obs photos from the Gemini and Mercury missions, and I don't know the date off the top of my head.
Right.
But, basically, the duration of NASA manned space flight, we've got it.
Gotcha. As long as we've had somebody in space to point a camera back down at the Earth and hit the button, we've got pictures from there.
Yeah, for the most part. There's still some film photography from shuttles that are being scanned and digitized,
right?
And those are still being added to our database on a weekly basis. So,
gotcha.
I won't say it's every photo because I know that's not true. There's going to be more that keep getting added, but it's a large majority.
Gotcha. Excellent. So the last question here, this one's mine. Don, we know that you're in the workshop right now, right? And kicking back to a previous Intrepid Virtual Astronomy event, we did a little bit of a thing for DM2, the crewed mission going up to space, and talked about how the spacecraft protected the astronauts from vacuum. You have like a big vacuum chamber in your lab there, don't you?
I do. It's right here.
And that goes down to like lunar vacuum? What were you telling me?
It's got what we call a turbo pump.
Right.
And so I could, in this system, because it's got a bunch of Phaeton O-rings and things like that, which degas a little bit, I could get down to about 10 to the minus 8 torr, which maybe at solar noon on the moon, the atmosphere on the moon might be up to that kind of pressures.
So my tie-in, since you have this really cool vacuum chamber there, back to our previous virtual astronomy event, have you ever put a marshmallow in it?
No, I haven't, because you want to keep your vacuum systems clean.
Right.
You don't want a bunch of gunk in there, because it just sits there and smolders and degasses, and you'll never get down to pressure again.
Gotcha.
And so when I open this system up, I wear rubber gloves.
You keep it really clean.
I like to keep it clean, and putting a marshmallow in there, that would be sacrilege.
That would be sacrilege. I ask because one of the previous virtual astronomy events, the demonstration was a little sort of vacuum chamber, like the little dome you put down over something, a little pump, you pump it out, and we demonstrated that the marshmallow gets really big, right? So you have like an actual scientific system there. We're not going to put any marshmallows in there. I had to ask that myself because I was curious, and I also wanted you to show off your vacuum system.
Good question.
Let's hop back over to Summer Ash, because once again, unfortunately, we have run out of time for our virtual astronomy event here today. Summer, welcome back. All right. Oh, you might be muted there. It's okay.
I did it.
There you go. You did it. Nice.
Has to happen
Summer,
once,
welcome
right?
back.
Thank you. I was just going to say that the this gateway to astronaut photography of Earth, I think, is an excellent substitution or replacement for doom scrolling.
Scrolling?
In the middle of the night in this current world. This will help. This will actually be kind of the opposite of that.
Just paging through pictures that were taken from space instead of the latest news that's on social media or whatever, huh?
Sounds much better.
All right. Well, everyone, like I said, that does bring us to the end of our show here today. Summer, thank you so much for hosting today. We appreciate you, as always. Always a good time to have you stop through. Don, thank you so much for the time joining us from over there in Houston today. We really do appreciate you joining us. And Andrea, thank you as well for dialing in here for our virtual event. Did I miss anything? Any last statements? Anything that y'all wanted to say that you were like, Doss won't stop talking. I wanted to say this.
I've got something, John.
Good.
I just want to point out that art is an inevitable consequence of being human.
Okay.
Even in space.
In space. So when you get there, you, being a human, you have almost an imperative desire to create art, or you're almost driven to create art. Is that sort of what you mean?
Yeah. I mean, when we were living in caves, we did that. And when we were going out and about doing other things, we human beings, it's inevitable. Human beings create art wherever they happen to be, even in space.
I like that. We have it right there. It used to be STEM, and now it's STEAM because we put the arts in there. We're not just engineering. We're just not solving problems. We're just not exploring. We're also artistic beings. So I think that's a really potent thing to say. Thank you so much. Andrea, did I miss anything?
No, I think we're good. Thank you.
All right. Okay, y'all. So we'll go ahead and call it an end to our virtual astronomy event here today. I do want to reiterate the Intrepid Museum's Virtual Astronomy Live is made possible by the New York State Council on the Arts with the support of Governor Andrew Cuomo and the New York State Legislature. Virtual Astronomy Live is also generously supported by the New York Space Grant Consortium. Like I said, these things don't just magically appear because somebody accidentally stumbles onto a Zoom call. It's all the coordination that occurs. Everybody on the call right now came through and did technical checks with us, and we did some run-throughs. We talked about what's happening. So really, everybody here, I appreciate your time, not just today, but all the stuff that we did leading up to this. I hope y'all had a good time today.
Absolutely.
All
Thank
righty.
you all.
Bye now.
All right.
Bye,
As a quick reminder, our next Virtual Astronomy Live program is going to be on Thursday, August 20th, and we'll feature spaceflight and gaming. So for more information, you know the website here. Go to intrepidmuseum.org to find out about our next event coming up in August. One more time, y'all, thank you so much for joining us here today. I got to get the little outro things out of the way. It's like, read this real quick. So there we go. So we can keep on doing these events. But I appreciate y'all showing up, and we will see y'all next time. Thank you very much again.
Bye, y'all. Thank you.